Hello everyone. Today we will be discussing the mathematics of basketball. And so there are three primary applications of mathematics in basketball that we will be looking at today. The first of which is statistics. And its main concepts include percentages, averages, ratios, and probability. And statistics is crucial when it comes to analyzing a game of basketball. It is typically used to determine the strengths and weaknesses, value, and performance of not only each player, but of the team as a whole. And percentages come in handy here. We can calculate the percentage of missed shots, the percentage of shots made, the percentage of steals, and the list goes on. And with these percentages, coaches are able to gain an understanding of an individual player's needs and abilities and what they have to address. And it also allows coaches to rank their players as well. In addition to percentages, we have averages and ratios, and they play a pretty important role in the mathematics of basketball because they allow us to calculate values like the points per game average or the turnover to assist ratio. And lastly, we have probability. Probability is not as prevalent, however, its application is pretty interesting. One way it can be applied is predicting the best time to take a shot. Crazy, right? But it's possible. Using the probability a given shot will go in, the quality of future shots a team is likely to generate, and the number of shots left before players have to forfeit the ball to the opposing team, a model can be created to predict the optimal time for a player to shoot the basketball. It is a complicated concept involving several complex physics and mathematical equations, but the idea of it is that through probabilities, basketball players can determine if it is the best time to shoot the basketball or pass it on to another player. So as you can see here, statistics concepts apply to the mathematics of basketball, and there are a lot of statistic concepts. And that may seem a bit scary, so let's go through an example to clear up any confusion you guys may have. So, if we look at this table right here we have the number of three-point field goals, the number of three-point field goal attempts, and the three-point field goal percentages. And this is for LeBron James and Steph Curry. And with this data, we are able to determine the individual three-pointer accuracies of both LeBron James and Steph Curry, and we can compare them too. Let's start with LeBron James's data. So if we look at his three-point field goal percentages, and if we calculate the average, we can establish that on average, LeBron made 40% of his three-pointers in 2017, which is when this data was collected. And if we do the same for Steph Curry, we can see that he made 39% of his three-pointers in 2017. So if we were to compare their individual three-pointer accuracies, it's evident that both of them have around the same accuracy. But you could also rank these two players based on their accuracy. And in this case, Curry would be ranked second with LeBron in first, but it's a pretty close tie. So hopefully this example clearly demonstrates the role of statistics in the mathematics of basketball and also clears up any confusion you guys may have and just shows how statistics applies. So moving on, we have geometry. And the main concept here is angles. And we also are going to discuss geometry's relation to algebra and a little bit of physics. So, if we look here at the form of the player who is about to take a shot, it's pretty clear where the angles are. If we take a look at this image right here, you can see that there is an angle being made by the extension of the basketball player's arms and a perpendicular line that starts around the player's hips, roughly. And this angle is key to making a successful shot, because that angle which you throw the basketball with affects the trajectory. Trajectory is an algebra concept, and it's basically just the path that the basketball is going to take. So if we take a look at this image right here, you can see how the angle with which this basketball player throws the basketball affects the path or the trajectory of the basketball. And not only does the angle affect trajectory, but the distance from the hoop and the force that you launch the ball with do as well, which are physics or applied mathematical concepts. So I just gave you a lot of information on geometry and in relation to other areas of mathematics. So let's go through an example to illustrate how exactly angles, distance, and force each affect trajectory and your chances of making a successful shot, because don't we all want to get that basketball in the hoop? Okay, so let's begin with the relationship between angles and distance. Now keep in mind that when I talk about angles here, I'm referring to the angle that's made by the extension of the basketball player's arms and a perpendicular line that starts around the player's hips. And so the basic relationship, which you see right up here, is that smaller angles are optimal for shorter distances and larger angles are optimal for longer distances. How do we know that? Well, why don't you test it? Try throwing a basketball about 1 foot away from the hoop. What is your form going to look like? Well, the angle, again, the angle right here, made by the extension of your arms and a perpendicular line that starts around your hips, that angle right here is going to be pretty small, almost close to zero when you're only a foot away from the basketball hoop. And that just demonstrates this relationship that we were talking about earlier, that smaller angles are optimal for shorter distances. Okay, but what about the second part of this relationship? Larger angles are optimal for longer distances. Well, you can test that too. Try throwing the ball 10 feet away from the basketball hoop or even farther. This angle right here, it's going to be pretty big because if you shoot the basketball at a small angle, one that's almost close to zero, then the ball is barely going to travel horizontally across the court into the basketball hoop, since you're essentially throwing the basketball directly upwards above your head, kind of similar to setting a volleyball. And so considering these examples I just gave you, it's evident that the relationship between angles and distance is that smaller angles are optimal for shorter distances, and then that larger angles are optimal for longer distances. All right, so another concept I mentioned is force. This idea, it's fairly simple. If you apply too much force, your basketball is going to go flying, but on the other hand, if you apply too little, it's not going to move much. And finding that middle ground is key towards making a successful shot. Determining that middle ground actually relates to distance. If you are, again, 1 foot away from the basketball hoop, not a great amount of force is required, but if you're 10 feet away, you're going to need to apply a decent amount of force if you want your basketball to travel across the court successfully. And you can, of course, test that yourself. Try throwing your basketball with a little force and then try throwing it with a lot of force and see the difference it makes in your basketball's trajectory or the path it takes across the court and how it further affects your chances of making a successful shot. Now, considering all of these concepts, geometry, so angles and its relation to algebra and physics concepts or applied math concepts, we can see how they affect the trajectory of a basketball or the path the basketball takes. And moreover, how that trajectory looks is going to essentially determine whether you make a successful shot or not. And so that's it. That is the mathematics of basketball. We have some statistics in there, a little bit of geometry, some algebra, and even a little bit of physics or applied mathematics. And they all apply to this wonderful sport of basketball. Now, if you are still curious and want to learn a bit more, you can check out these sites. This one right here, it's an article, don't worry, it's short, and it covers probability, goes more in depth about the model that you can create to determine the best time to make a shot. And this website includes some videos and interactive games and simulations you can play around with to learn a bit more about how mathematics applies to basketball. So finally, if you want to learn more about this nonprofit organization, Integrals Derived, and their mission to inspire and encourage all girls to embrace mathematics and its application, you can visit their website, integralsderived.org, or their Instagram @integralsderived, for more information.